Okay, here we go. Graph A and graph B. We're taking a look at these. Both graphs below are linear functions. One is a proportional relationship and the other is not. I want you to write down which one is the proportional relationship and how you know, and why is the other not a proportional relationship.
My mom bought this at a house.
The 4 normal.
It was an X one and just.
Oh, that is so cute.
That's so demure.
How much Eagles did it cost?
Bro, you already know the skin's free. Of course the hoodie's free too.
It's free.
He just had to log into Fortnite.
It's free.
He's had to log into Fortnite for the hoodie.
I don't even play Fortnite.
That hot dog 2011?
King Julian 1173.
I think.
That is so much better.
Where's the soul?
Bro, no way King Julian 1173 is still wearing his Halloween costume, bro.
I knew it.
Bro, I remember like over
Little Brian? Little Brian? I only have like 20 skins.
You played on Switch though.
Bro, I don't know Switch. I had over 100 skins on there.
I think I have like 240 skins.
Bro, I only use like 2 of them.
It's just because of the battle pass. I have so many skins. I know you got that Juice WRLD skin.
I don't play no more. I play Size.
Hey, what?
I play
What rank are you?
I don't play.
Lil Bro's in ranked version 2 and he isn't in it. Like, I think I peaked at diamond in like ranked 1, like the first rank. Then once they updated ranked, I peaked at like champ and then high plat.
But guess my level. Like,
I'm like level 146 on Xbox.
guess my level.
It's low. It has to be over 50 because that's when you unlock rank. It's like 74.
57.
I'm level 146. I peaked. I died.
Alright, sorry guys, I've got sick kids, so. Okay. Alright. Here we go. Sorry that took a minute. So, which one do you think is a proportional relationship?
Graph A.
A. Why? It goes through the origin. Why is B not a proportional relationship? It doesn't go through the origin. So we're going to say this one is our proportional relationship. Okay. For the proportional relationship above, what is the unit rate? So remember that's our Y value over our X value. So what is our proportional relationship? Our unit rate?
3.
3 over what?
1.
No, it's not.
Negative 1.
-1. So what does that really simplify to?
3. Negative 3.
-3. So there's our unit rate. Now, how we just did that here. I want you to try that for graph B because that was our one that's not a proportional relationship. I want you to try that. Does it work? does that work for this one? Because then that'd say it's 2 over 2. Is that right?
No.
No. So the way we were doing unit rate before, it only works if it's a proportional relationship. It does not work when it's not a proportional relationship. So what I'm going to show you is something that works for both of them every single time. Okay? To find the rate of change, which is also called the slope, so in our equation y equals mx, the m, which you'll really know it as, is the slope. Very important. M is the slope. On a linear graph. A linear function or linear graph means one thing, straight line. If it's a linear graph or it's a linear function, it means it will be a straight line. Okay? Okay, so we're going to make a slope triangle. Do you see all these dots that we have? See all those? Okay. So those are going, what I call, do you see these lines in the background? How they kind of look like street intersections? Okay. That's where our dots are on, is right where you cross an intersection. You need to pick one of these sets of dots to make a triangle with, just like we did in Unit 2. They're all going to be the same. So make me a slope triangle on your paper, please. Okay, for this, what we call this is, we call this a rise over a run. The rise is your up and down, so 1, 2, 3. Your run is right and left, 1, 2. And when you're listing your slope, you're listing it as rise over run. So your rise is 3, your run is 2. And it didn't matter which one I used. I could have done this one too. 1, 2, 3, 1, 2. It doesn't matter. Questions on our slope? No? Okay. These next two content objectives, you're going to be finding the slope using either a slope triangle, or we're going to use the slope using the slope formula. Today we're going to focus on the slope triangle. Okay? So we've got a graph right here. I want you to draw your slope triangle on that graph. You only need to draw one. It doesn't matter which two you use, but it is helpful if you use the closest two. So I could use these two like that, but they're not the closest two, which means you're going to have to simplify. Stop with the tapping, guys. What's your rise? What's your rise? 1. What's your run? 2. Now something I haven't shown you yet. I want you, if you look left to right on your graph, which way is your line going? Up or down? It's going down. So that tells me that this slope is negative. When you're listing a slope as negative, you can write it like this, where the negative's in the top like that. You can write it like this, where the negative's out front of everything. But you may never write it like that, where the negative is in the denominator. So, yep, so if the line goes down, it's a negative slope. If it goes up, it's a positive slope. But don't ever write it with a negative in the denominator. Does that make sense? Okay, we're going to go ahead and switch gears to our presentation.
Little bro thinks he's in the attic.
Excuse me, sir. I think you're not in there.
You said 8.
Okay. We're going to switch gears to that presentation I just gave you. Okay. I can use slopes triangles to find the slope of a line. That's what we're focusing on today. You need to know CO3 and CO4 in order to do any of Unit 4. These are very important because I'm not going to reteach them and I'm going to expect that you know them next unit. Okay? All right, so here we go. We've already got our slope triangles drawn here for us. Just kind of, it can go this way too. It doesn't matter. Just like when Unit 2 we were doing, where we drew in the triangle, it didn't matter if we went on the bottom or we went on the top, right? What's our rise here? 1, -1, either way. 2 is my run, right? What's your line doing left to right? Going up or going down?
Down.
So what does that tell you about this slope?
It's negative.
It's negative. Where's the only place I can't put the negative? In the denominator. Can I put it out front?
Yeah.
Can I put it in the numerator?
Yeah.
But I cannot put it in the denominator. Okay. This one here I put on here a couple of reasons. You can see that the rise is 2 and the run is 2. Agreed? But remember how I was talking about those intersections and it's where our graphed line goes through one of the intersections? Do you see that that also happens right there? So my rise really could be 1 over 1. Does everyone see that? We want to try to do the closest ones because then we know they're simplified. Okay. Flip the page. These look a little different. In C, do you have a rise? Do you have a rise?
Yeah.
What is it?
Plus 3.
What's your run? Is there a run?
No.
No, it's 0. I want you to grab that calculator that's in front of you, please. What do you notice you got when you typed that in? Did you get a domain error?
Yes.
Yes, this is called undefined. Here's why. If I have 3 apples, can I put them into 0 groups?
No.
No, because I'd still always have a group of 3 apples. You can't take any number of something and put it into 0 groups because you're still always going to have a group. So let's look at D now. Do I have a rise?
Yeah.
On D, I have a rise. That's my run.
Oh, 3.
So I have a 0 rise and I have a run of 3. Type that into your calculator, please. What'd you get when you typed that into your calculator? 0. The reason for that is if I have 0 things, can I put them into 3 groups?
No,
Why not?
because you don't have any.
Yeah, I did. So could I have 3 groups of nothing? I could have as many groups as I want. And they'll all have how much in it? 0. So I can have 0 things and put them into 3 groups because each group will have nothing. So that's what it's saying. Each group would have nothing. So that's why this one is undefined. This one is 0. Does that make sense? All right, I want you to try to do this. Identify the slope of the line. Draw your slope triangle.
Bro.
Okay. Okay, so couple of things you could have noticed here. One, do you see that it goes through the intersection right there? And you could have put that dot in if you wanted to. I'm guessing most of you did this. Would I be correct? Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So 6 over 4. But that's not simplified then. So I need to divide this by 2. And I get 3 over 2. But what's the direction of my line? Going down, so what do I need to say about this slope? Negative. Now, if you saw that extra dot you could have put in, that they did not. 1, 2, 3. 1, 2. Do you see why you want the dots that are closer? Does that make sense? Okay? That's why we want that. And then always make sure you're looking left or right to know if it goes up or down. Okay. We're going to graph these lines, these points, 2, 7, and 1, 5. So we're going to go over 2, up 7, and put a dot. Over 5, up 1, put a dot. And then we're going to draw our line. We are now looking for the slope of that line. So let's draw on our slope triangle. My rise is 1, 2, 3, 4, 5, 6. Over 1, 2, 3. Is that line going up or down?
Down.
Down. So what do I need to make this?
Negative.
Okay, but is this simplified right now?
No.
No. what would this simplify to?
2 over 1.
2 over 1, which is really just 2. If you leave it 2 over 1, that's fine. If you simplify it out even farther and put negative 2, that's also fine. Why did I put the negative?
Because it goes down.
Because it goes down left to right. Okay. I want you guys to try to graph this point and find me my slope. Graph those 2 points and find me my slope. Okay. So we got to graph these 2 points. Remember that first number always means right, left. Second number means up, down. Okay, so I'm going to go over 0, up 1, over 2, up 4. Do you guys agree with that?
Yes.
Okay, so I've got my line. And now it's asking for my slope triangle. Is it okay if I draw my slope triangle on the top or the bottom?
Yes.
Doesn't matter, right? What's my rise?
3,
What's my run?
2,
Okay, and is your line going up or down, left to right?
up.
So what's that tell you about your slope?
It's positive.
It's positive. Are we understanding this so far?
Yes.
Okay, let's go ahead and go to the back here. We're almost done, guys. And then I have so many kids missing homework. Okay, we're going to graph this one now. I want you to graph these 2 points and find me my slope. Okay. Over how many?
3.
3 up.
7.
Over how many?
-1.
Up.
5.
All right, so here's our line. Do you agree with my line?
Yes.
Does it matter if I make the triangle on the top or the bottom?
No.
No. What's my rise?
2.
What's my run? Is that simplified?
No.
No. So I'm going to divide this both by 2, and I'm going to get what?
1/2.
1/2. Final thing we need to look at, is that line going up or down?
Up.
So what does that tell you about the slope?
It's positive.
Positive. So here's my answer. Questions on that so far? We're doing all right? Okay, I'm going to switch it up just a little bit. We're almost done, guys, so thank you for being patient with me. Okay, this one, it kind of switches it up a little bit. It says, graph a line with a slope of 2. There's no starting point was given. Put a point anywhere on the graph. So take your pencil and put a point anywhere on the graph. Okay, I'm going to put mine right here. Does yours have to be in the same spot as mine?
Nope.
No. It says the slope of 2 can be written as 2/1. So then that gives us our rise, and it gives us our run. Okay? From that point, put your pencil on that point. I want you to do a rise of 2, so go up, 1, 2, and a run of 1, and put another dot. So from the point, you rise up, 1, 2, and a run of 1. Okay? Do you see, if we were to draw our slope triangle now, what would our rise be?
2.
What would our run be?
1.
1. So did we, in fact, draw this appropriately?
Yes.
Yes. Did that make sense of why we did that? What happens if I would have rose up 2 and went 1 this way? If I would have went up 2 and over 1 this way and put my dot there, what would have happened with my line?
It would have been negative.
It would have been negative. And is my slope negative or not?
No.
No. Oh, sorry. What the heck just happened? That's not what I needed to happen. Okay, go ahead and flip to the next page. All right, you're going to see it says -1/4. So you're going to do the exact same thing that you were just doing, only now it's -1/4. Okay. You can put the pi anywhere you want, right? I'm going to put it, I don't know, right here. Did you have to do the same point? No? It says, but notice here, what's this say? Negative? Okay. So I'm going to go down 1 because it's a negative. And then I'm going to go, my run's over 4. 1, 2, 3, 4. Does that make my line negative if I do that? Does it? Do I need to have my dot in the same spot as you? No. You were just putting that point somewhere. And you were making a slope of negative 1/4. Do we understand how to do the slope triangle? Is that making sense? Highly important for Unit 4. If we don't know how to do that, Unit 4 is not going to be fun.